Hey everyone, and welcome to This Explainer. Today, we're putting on our senior engineer hats to diagnose and fix what is absolutely the most critical bottleneck you will ever face in Grafana Loki. We're talking about label cardinality. Right, let's just jump right into it. Picture this scenario. Your Loki queries are constantly timing out, your dashboards are crawling, and out of nowhere, your infrastructure bill is just spiking. So what's the culprit here? Well, it's a painfully familiar situation for anyone running a large-scale observability stack. But the root cause might actually surprise you, because 9 times out of 10, it is your labels. Here is our quick game plan for today. We're going to cover the silent performance killer, then compare labels to structured metadata, break down good versus bad labels, show you how to check your own cardinality, and finally, we'll walk through a real-world incident response. Let's kick things off with part 1, the silent performance killer. So what exactly is label cardinality? Well, technically, it's the total number of unique combinations of label keys and their corresponding values. And this math directly dictates the exact number of log streams your system creates. Here's why this is so absolutely crucial to understand. Unlike traditional search engines that index the entire text of a massive log file, Loki doesn't do that. It only indexes the metadata. The actual log data, that's just compressed and stored away in cheap object storage. Because of this architecture, the sheer volume of your unique label combinations becomes the ultimate governor of whether your system flies or crashes. Let's do some terrifying math, okay? 250 million. Just imagine you have a perfectly healthy cluster humming along with around 2,500 active streams. Life is good. But then, someone on the team accidentally adds just one single dynamic label for a user ID. And let's say you have 100,000 unique users. Well, 2,500 streams multiplied by those 100,000 unique values geometrically explodes your stream count to 250 million. Boom. This forces Loki to create millions of separate index entries and flush thousands of tiny, highly fragmented chunks to storage. It will literally melt down your index. Moving right along to part 2, labels versus structured metadata. To fix this, Grafana introduced a major architectural evolution. On one side, you have index labels. These should be used strictly for coarse routing and basic stream identification. Because they define your streams, their limits are incredibly strict. On the flip side, we have structured metadata. This data is stored directly inside the compressed chunks themselves, completely bypassing the index. Because it's stored in the chunks, it natively handles unbounded, massive cardinality values without breaking a sweat. It is the absolute perfect home for those noisy OpenTelemetry attributes like trace IDs or pod names that would normally destroy your index. Which brings us to part 3, good versus bad labels. There is a very strict line in the sand when it comes to what data is actually permitted inside a label. Good labels, things like your environment, the service name, or the region, these describe the source of your logs. They're strictly bounded and static. You generally know how many environments you have, right? But bad labels, things like user ID, request ID, or session token, these describe the content of the logs. They're totally unbounded and highly dynamic. If you use these as index labels, they will bloat your memory and fracture your data, for sure. So, what are the golden rules every SRE needs to memorize right now? First, completely avoid dynamic labels extracted from your log content. Just use filter expressions at query time instead. Second, try really hard to keep a single tenant to under 100,000 active streams. And third, strictly adhere to Loki's default limit of 15 index labels. Look, adding extra labels only inflates your time series database index and kills performance. A good rule of thumb, if a term is only searched maybe once a year, it simply does not belong in your index. All right, part 4, checking your cardinality. You might be wondering, am I at risk right now? Well, here's how you find out. Running the log_cli series command with the -analyze labels flag over the last hour is hands down the absolute fastest way to debug high cardinality in your own system. When you run this, Loki analyzes your streams and points out precisely which label has the highest unique value count. It's a game changer of a tool for figuring out if a rogue request ID is secretly hiding in thousands of your streams. And finally, part 5, incident response. Let's fix Loki. Okay, put yourself in the hot seat. Your team's Loki instance has slowed to an absolute crawl. You check your monitor and bam, there is the dreaded PagerDuty alert, error, max global streams per user exceeded.
Yeah, that is a terrifying message to wake up to. It typically means you have a catastrophic cardinality explosion happening right at the ingestion layer. Your stream count has multiplied completely out of control, and Loki is actively rejecting writes with 400 bad request errors just to protect its own memory.
So, deep breath. How do we fix it? Let's step calmly through the resolution. Step 1, we run that Analyze Labels command we just talked about to hunt down the rogue label. Step 2, our analysis shows that a user ID field was accidentally pushed to the index during a recent deployment. Whoops. Step 3, and this is the crucial part, we configure our log collector, whether that's Grafana Alloy or Promptail, to strip user ID out of the labels and demote it into structured metadata. The second you move that unbounded value out of the index, the bleeding stops. Your stream count plummets back to normal, and the incident is resolved. And making this switch gives you a massive performance recovery on the read side, too. See, a slow query that relies purely on an indexed user ID equals 123, that is exactly what causes these explosions. But look at the fast query. We use a bounded label, like app equals frontend, to quickly grab the write stream first. Then we just pipe that and filter the structured metadata for the user ID. Doing this leverages Loki 3.3's experimental Bloom filters, which lets it scan structured metadata at absolute lightning speed with 0 index penalties. By the way, you can actually go test these exact query performance differences yourself over on play.grafana.org. Highly recommend checking that out. Which leaves us with one final question for you to chew on. When was the very last time you audited the cardinality of your own observability stack? I challenge you to take these senior engineer best practices back to your dashboards today, go check your streams, demote those high cardinality labels to structured metadata, and watch your system stability and performance absolutely soar. Thanks for hanging out with us, and happy querying.